Okay guys, we are in our last lesson for this unit. It's over inverses. Hopefully this will be a review because we've done inverses for each one of our previous functions. Inverses, remember, is nothing more than taking the x and the y and switching places and then solving for y. This information in this little box is important. The graphs, the inverses of the graphs will be always reflected over y equals x line, which is our parent function. The range of the original will be the domain of the inverse, and the domain of the original will be the range of the inverse. So for this first one, we're going to rewrite it. Y equals to 3x minus 4 cubed minus 5, and we're going to find the domain of our original. Well, since it's a cubic function, the domain is always all reals. Now we're going to switch places. So we have this. Then we're going to solve for y. So we have to get rid of the 5 first. Then we're going to divide by 2. Then we have this. To undo cubed, we're going to take the cube root of both sides. So now we have this. And then what we have left inside is we have to add 4. So it's going to be cube root x plus 5 over 2. Add 4. Then we have to divide by this 1/3. Or we're going to multiply by 1/3, which should be a lot easier. So it's 1/3 there. And then your 4 also has to be multiplied by 1/3. You get 4/3. This is my inverse. I have to find the domain again. This is a cube root function. Cube root function, no restrictions. So your domain for both is negative infinity to positive. Okay, so this next one says find the inverse of f of x equals x squared minus 2. And it's restricting your domain. And the reason why it's restricting the domain of the original is so that the inverse can also be a function. So when we graph this, it's a quadratic. Move down 2. So we're going to go over 1 and up 1, over 2 and up 4 because it's a quadratic. We're squaring. Then we're going to reflect it. This is what my original graph is going to look like. Okay? Now, we're going to find the inverse by switching the x and the y. So we have this. So we add 2. And we take the square root. So our domain of this one has to be positive. So your domain is going to be -2 and greater. Okay, so go back to your graph that we just graphed. It says that the domain is greater than or equal to 0, which I forgot to do. That means we are not looking at this side of the graph because we're only going to look at x is greater than or equal to 0. So we're going to end up with that, just half of the curve. So when we flip that and graph, when we graph this, our square root function, it is going to start at -2. We're going to go right 1, up 1, right 4, up 2. And we are going to get this curve like that. These two graphs are inverses of each other. They are reflected over this line, y equals x. And you can check it by taking your orange points and reflecting it. So this coordinate, this first one, is 0, -2. Well, you can see that my first purple point is -2, 0. You're switching your x and the y. What would happen if that restriction at the very beginning wouldn't be there? Then we would get the inverse would not be a function. Okay? So you have to restrict both the inverse and the original. On this one, they give you a graph. So it says find the inverse of the function below, the domain of f of x and f of negative x on your graph. So this one is our original graph, so this is f of x. So f of x, the domain, is going to be from negative infinity to 0. When I take the inverse, I'm going to take my points. On this one, it's 0, 1, 2, 3, 4, 5. So my inverse point would be 5, 0. This is 1, 4. So it's going to be 4, 1, 0, 5, 4, 1. Be there. And it is going to be going that way. So it is reflected over f of x. So my domain for my inverse is going to be from negative infinity to 5. And this, I messed up. Go back to your domain for your first one. That should be from 0 to positive infinity. Like that. Write the equation of f of x. So if we wrote this original equation, my original equation is a square root curve that has been reflected over the x. So this would be x, and it's been moved up 5. That's your original. Then you can solve it by switching your x and your y. Okay, so example 4, find the domain, the range of this. We're going to do that first. So my domain, I'm going to take what is underneath the radical, which is 3x minus 2, and I'm going to set it greater than or equal to 0 because it has to be positive. So that means x is going to be greater than 2/3. That's your domain. My range, it's been moved up 7. So it's from 7, positive infinity. I'm going to solve the equation for the inverse. So f of x, I'm going to change the x and the y. So we have this. So I'm going to, the inverse of a square root function is a quadratic. So I'm going to subtract the 7. I'm going to square it to get rid of the radical, and I'm left with this. I'm going to add 2. Add 2. And I'm going to divide by 3 or multiply by 1/3. Since I already have stuff, I'm going to multiply by 1/3. So that means 3 is also, the 2 is also going to be multiplied by 1/3. And my inverse equation is this. My domain, I have to look what's right there because that's going to affect the domain of the inverse. So this is going to be x, it's going to be 7. Well, you can see that the domain and the range are reflected. So this is going to be 7 to positive infinity. This, I messed up. This should be the opposite way. It should be infinity to 7. And then your range would be that. And you can see that right there. It has been moved up 2/3. So my range would be positive infinity 2/3. It's the inverse. Okay? All right, so example 5, find the inverse, restrict the domain if needed so that it makes it a function. So this has already been restricted. So I'm going to switch the x and the y. I'm going to divide by negative, so I have negative x equals y squared, and then I'm going to take square root, so the inverse I'm going to take what is inside my radical, and I'm going to set it greater than 0. So this is greater than or equal to 0 because it has to be positive. So x is greater than or less than or equal to 0. So my domain would have to be x is less than or equal to 0. What's your domain? So both domains on this one are the same because it restricted it up here. Okay, so this one, restrict the domain if necessary. Well, it is necessary because I cannot have a negative under the radical. So x has to be greater than or equal to 3. That's for the original. My inverse is x equals 2, switch the x and the y, divide by 2. Then I have to square this. And then I have to add 3. So this would be x squared over 4 plus 3 equals your inverse. Okay? And this can be written as 1/4 x squared plus 3, inverse. And on this one, my inverse, the domain, the x has to be greater than or equal to 0 because of the inverse function of it, which would be original. Because if you look at this, the range for this starts at 0. The range is from 0 to positive infinity. Well, that's the reason why the domain is also greater than or equal to 0. Okay, so I'm going to restrict this. The domain for this, I'm going to take 2x minus 3 over 4, and I'm going to set it greater than or equal to 0. So my domain is going to start at 3/2. It's going to go to positive infinity. So I'm going to switch my x and my y. 2y minus 3 over 4 minus 2. Add the 2. Then I'm going to square it to get rid of the radical. So we have this. Then I'm going to multiply by 4. And I get this, 2y minus 3. I'm going to add 3. Plus 3. And then I have to divide by 2. Okay, for this one, I'm going to multiply by 1/2 because I already have things on the outside. So my inverse is going to be 2. Oops, sorry. Got ahead of myself. 2x plus 2 squared plus 3/2. My domain is going to be, you're going to take this part, your domain is going to be from -2 to positive infinity, and my range is going to be right there from 3/2 to positive infinity. And you can see that is the inverse of that domain. The range for this one is going to be from -2 to positive infinity because of this. And you can see that that is the inverse of the domain and the range are inverses. Okay, so I'm going to restrict this. So my domain has to be from 3/2 to positive infinity. Then I'm going to switch my x and my y. So x equals, 4, 2y minus 3 plus 1. So I subtract 1, divide by 4, squared, and now I end up with 2y minus 3. Okay, then I want that 4 out, this one. So I'm going to square, so it's going to be x minus 1 squared times 1/16, 4 squared, 16. Then I'm going to add 3, and now I'm left with 2y. So I'm going to multiply everything by 1/2. So if I do that, I get 1/32 x minus 1 squared plus 3/2. That is my inverse. My domain for this is going to be, you take this from 1 to positive infinity. Look up at your original, your range would be 1 to positive infinity. They're inverses of each other. Okay, all right, so to check to see if a function is a one-to-one, then you would do the horizontal line test. To see if the inverse is going to be a one-to-one, you do a vertical line test. So determine if the if the function's inverse is a function. Well, this, your domain for absolute value, that is going to be all reals. Your range, though, is going to be from 0 to positive infinity. So when we flip it, unless you restrict, your inverse is not going to be a function. Remember, absolute value looks like this. So if I go over 3, that's going to be the original. If I flip that and make my x's be my y's, it's going to be laying on its side, and it is not going to pass. This passes the vertical line test, the original does, but when I switch it, it's not going to pass the horizontal. It says right there, if it passes the horizontal line test, then that means the function inverse is a function. This would be no. This is a cubic function. Remember, a cubic function, our cube root and cubic. The cube root, it's on its side. Cube root is a snake like this. So this would be, yes, it is. The function, this is your function right here. If I do a horizontal line test on that, then it is going to pass the horizontal line test. X minus 4 squared minus 3. Okay, for a squared function, remember that that is going to be like this. It's going to be a U. If I do the horizontal line test, it's not going to pass. So this would be no. So to see if an inverse is a one-to-one, you take the original function and do a horizontal line test. All right, composition. Composition, remember, means to put one inside the other. And if they're inverses, you're going to end up with just x. So if I do f of g of x first. This would be 3 1/3 root x minus 1 squared. So I took this function and I put it inside right there. And then I still have minus 1. Everything else stays. So when I square this is going to be 3 times 1/9 times x minus 1. So this would be 3 times 1/9, or let's take care of the inside. This would be 3 times 1/9 x minus 1/9 minus 1. So this would be 1/3 x minus 1/3 minus, we're going to do 3/3. This is not going to give us an x value. So these are not inverses of each other. Okay. Let's do this one. Okay. Take your f of x. We're going to place it with g of x. So my f of x is this, the cube root. I'm taking this and putting it in for x. So this is 5x cubed minus 9 plus 9 over 5. Well, these cancel, this cancels, and I have the cube root of x cubed. That's x. That works. Now if I do it the other way, 5 cube root x plus 9 over 5, and this is cubed minus 9. Well, this all cancels, this cancels, plus 9 and negative 9 cancel, and I'm left with x. So this answer is yes. And that is the end of this lesson.